had a question about knowing which side to shade for this particular question. So I'm going to actually back it up a second and start with there are two forms that we're going to see lines presented in standard form and slope-intercept form. So when we have one in slope-intercept form like this, we would use the intercept and slope to graph. So this would be there. So we'd be at -3, and then our slope is 4/3. So we run 4 up 3. And then where are the y's greater than that line? Up here. Because if we're looking at y values, we're saying this side's going to be greater, this side's going to be less. So when they're in slope-intercept, we can just look at the greater than less than because it's a variable over here. When we have this kind, which is the one that you had the question on, in standard form, we graph it a little bit different. I would use intercepts, so when x is 0, y would be 2. Oops, there we go, 2. Oops, so we'll do that one because that's the right one. And then when y is 0, x will be 4. And so we would have that. So then we're trying to figure out which side to shade. So when we're in standard form, the looking at it and knowing based on something above or something below is not clear. And so what I suggest is you just do a test point, because either this side will work or that side will work. So I always test 0, 0 because it's super easy. 0 plus 0 is greater than 8. If that's true, I shade this side. If it's false, I shade that side. And again, if I plug in 0, 0, 0 is not greater than 8. So 0, 0 would not satisfy this inequality. It comes up with a false statement. So that means the other side must be true. So if it's in slope-intercept, you can just look, is this supposed to be greater than, above, less than, below. But as soon as they change it out to standard form, whoops, like this one, sorry. If it's in standard form, you gotta do the test point. Hopefully that helps.